Today we are going to discuss about Bragg's equation. Bragg is a scientist who gave a relationship between interplanar distance, wavelength of an X-rays and the angle of diffractions of X-rays. He studied clearly regarding the crystal surfaces of solids, and he was able to give an equation for solid crystal surfaces which we can be able to determine the distance between two planes and the angle as well as wavelength. So the first point, Bragg proposed an equation. Bragg proposed an equation to explain the relationship between interplanar distance which is represented with d, wavelength of X-rays, wavelength is represented with lambda, wavelength of X-rays, and angle of diffractions. Angle of diffraction. So let us discuss about this equation. Bragg let two X-rays of wavelength lambda are incidented on two parallel crystal plane surfaces. This is an first plane and this is second plane. This is nothing but a solid crystal surface. This is a solid crystal surface, and another one, this is third plane. And what Bragg did is, he have incidented an X-ray, first X-ray on first plane or solid surface, and this has been got reflected. This is nothing but an angle of incidence, and the point at which the X-rays have touched is, I am giving a name of point A, and this is first X-ray, and the second X-ray which is diffracted from a point B. This is called point B, and this is second X-ray. Let the distance between these two planes be d. The distance between these two planes, let us assume that this is the distance between the two planes is d, and this is nothing but, when I draw a line like this, I will get the distance as d. And if you observe very carefully, the second X-ray is diffracted from the point B. The second X-ray has traveled some extra distance than that of the first X-ray. This extra distance is called path difference, and this path difference, let us, the extra distance traveled is, this is the extra distance traveled, and I am giving as C, and the same is equal over here also, and I am numbering it as D. The angle between this is theta. The angle between this is also theta. This is theta. Let us write point wise. Both X-rays undergo diffraction. This third point is first X-ray is diffracted from point A in the first plane. Coming to the next point, second X-ray is diffracted from point B in the second plane. Coming to the next point, this is nothing but the second X-ray traveled some extra distance. This extra distance can also be called as path difference than the first X-ray. This path difference is equal to CB plus BD. Coming to next point, according to Bragg, the path difference must be an integral multiple of wavelength lambda. That is nothing but CB plus BD equal to n lambda, where n is equal to order of diffraction. Any integer, if it is in 1, then it is called first order of diffraction. If it is 2, second order of diffraction. If it is 3, third order of diffraction. We all know lambda is nothing but a wavelength. If theta is the angle incident and d is the distance between the two parallel planes, then we can observe that there are two triangles are formed in this. One is triangle ABC, another one is triangle ABD. Applying trigonometry from triangle ABC, we know CB by AB, where AB is nothing but D. Then sin theta, we are applying sin theta is equal to CB by AB, that is equal to CB by D. CB is equal to D sin theta. Let this will be the equation 1 and this will be equation 2. Similar in case of another triangle, from triangle ABD. Sin theta is equal to BD by AB. BD by AB. We know already AB, BD is nothing, AB is nothing but D. So BD is equal to D sin theta. This will be equation 3. Substituting equation 2 and 3 in 1, we get n lambda is equal to D sin theta plus D sin theta. N lambda is equal to 2D sin theta. This is known as Bragg's equation. Just have a screenshot of it. This is what regarding the Bragg's equation. Very simple equation that was derived by Bragg.